Good morning. In last lecture we have discussed the concept of photodiode, pin diode. In this class also we are discussing the applications of photodiode and some more concepts. You are welcome in Sanjeevanee Mahavidyalaya, Chapoli. This class is for B.Sc Physics second year students. Paper number 9, Basic Electronics. In last lecture we have seen about photodiode, its characteristics, how to improve its sensitivity. By increasing temperature or by increasing reverse bias voltage. Dark current increases, but in order to improve the sensitivity of the photodiode, dark current should be minimized. So, in order to minimize the dark current, reverse bias current or reverse bias should decrease. As a result, there will be the improvement in the sensitivity of the photodiode. This concept already we have discussed. Further, in electrical engineering, dark current is the relatively small electric current that flows through photosensitive devices such as photodiode, even when no photons enter on it. Whenever there is no entry of photons, no photons are incident, then also there is a flow of current, that is dark current. Though it is very small, but there is a dark current. The dark current serves as a basic current that cannot be avoided. If the dark current is minimized, the sensitivity of the photodiode increases. This is the main concept in photodiode. Due to increasing demand of photodiodes in electronics industry, it becomes most versatile and efficient diode. It is used in medical industry such as detectors for computed tomography and pulse oximeters. It is used in barcode scanners and position sensors. It is used in optical communication devices and automotive devices also. It is used in consumer electronic devices such as receivers for infrared control devices, smoke detectors, compact disc players, etc. It is used in science industry for accurate measurement of light intensity also. It can be used to detect the presence or absence of minute quantities of light and can be calibrated very accurately for the measurement. So in this way, photodiode is very important. Photodiodes are also used to detect light and its intensity also. Photodiodes are used with IR LED for object detection, counting encoder, etc. It is also used in line follower and object avoiding a robot. It can also be used to detect the fire with proper tuning. It is also used to distinguish between day and night. Automatic light, that is street light or vehicle light, can be automatic light control. In such a system also LEDs photodiodes are used. Automatic light control, it may be street light or it may be of vehicle light. In such a control system, photodiodes are very applicable. Now we are discussing the another diode, that is a varactor diode. What about varactor diode? What is its symbol? Where it is used? What is its actual shape? All these things we discuss. This varactor diode has various names. It can be identified by various names such as varicap, volt cap, voltage variable capacitance, tuning diode. See, these are the four different names of varactor diode. Practically it looks like this. This is the symbol of varactor diode. So once more, it can be named as what? Varicap, volt cap, voltage variable capacitance and tuning diode. Its symbol is like this. Here arrow is there and here sign of capacitor, like this. This is your varactor diode. Varactor diode is nothing but again a semiconductor whose internal capacitance is proportional to, directly proportional to the reverse voltage or reverse bias. It works on only reverse bias. It is a voltage dependent semiconductor. Reverse bias dependent semiconductor. So remember, this is a voltage dependent semiconductor. It can be identified by different names: varicap, volt cap, voltage variable capacitance and tuning diode. This is symbol of again varactor diode. You see, this electrode is anode and this one is what? Cathode. Here again cathode and anode in this way, easily you can remember. The symbol of varactor diode is similar to that of the PN junction diode. The diode has two terminals, anode and cathode, unlike PN junction diode. Only there is just change in symbol. Symbol here it is like this. Two plates are there given, cathode side. The diode has two terminals, anode and cathode, unlike PN junction diode. Anode side is same to that of the PN junction diode. This anode side is same. It is exactly similar to the PN junction diode. Only thing is that cathode side you see. What is the difference? Cathode side there are two plates like this. And cathode side two parallel plates. They are showing a capacitor, condenser. A capacitor, you know what is capacitor? Capacitor is the electronic component or electronic gadget. It stores electrical energy or electric charge in the form of an electric field. It stores electric charge in the form of electric field. Such a symbol is showing towards cathode side. So there are different symbols of varactor diode. They are like this. Two plates like showing condenser like this, or in some cases it is like this, or in some cases it is not like this. Here variable type. This side is anode and this side is cathode. Exactly you see everywhere anode is like similar to the PN junction diode. Only there is a difference in case of what? Cathode. In some cases it will be like this, it will be like this, it will be like this. The function of varactor diode is to store charges. Its function and function of the capacitor is one and the same. It stores charges so that it is always operated in reverse bias condition. When a forward bias voltage is applied, the electric current flows. As a result, the depletion region becomes negligible, which is indesirable. That's why we say it works in, or it can be operated in, only a reverse bias. The junction capacitor of a PN junction diode is inversely proportional to the width of the depletion layer. In other words, if the width of the depletion layer is less, then the capacitance is what? More, and vice versa. If we need to increase the capacitance of a varactor diode, the reverse bias voltage should be reduced, decreased. It causes the width of the depletion layer to decrease, resulting in a higher capacitance. Depletion layers width decreases in the sense what? It possesses higher capacitance. Similarly, increasing the reverse bias voltage should decrease the capacitance. Increasing reverse bias voltage, decrease the capacitance. This ability to get the different values of capacitance just by changing the voltage applied is the biggest advantage of varactor diode when compared to a normal variable capacitor. If we compare normal variable capacitor and varactor diode, what is the ability of the varactor diode? The ability of the varactor diode is that we get different values of capacitance by just changing the potential difference. So, as compared to the normal capacitor, varactor diode is very important. Varactor diodes are mostly operated under reverse bias condition, and therefore there is no conduction. They are voltage controlled capacitors and sometimes known as varicap diodes. Although the word varactor diode is widely used, mostly varactor diode is used, but as it is a voltage controlled capacitor, that's why it is also said to be, it is also known as varicap diode. In this way, they are used in RF design arena and provides a method of varying the capacitance with a circuit by the application of control voltage. It provides them with a special capability due to which varactor diodes are used in radio frequency industry, RF industry. Varactor diodes are useful in RF industry, you remember, that is radio frequency industry. The applications of varactor diode, there are two main applications, FR filters and second one is voltage controlled oscillators. It is possible to tune filters by using varactor diode. Tracking filters can be required in front end receiver circuits, wherein the filters are enabled to track the frequency of incoming receiver signals. Second one is VCO, voltage controlled oscillators, are used for many applications in oscillators within a phase locked loop is the major reason. VCOs are present in almost all wireless receivers and radios. So remember, these are the main two applications of varactor diode, that is FR filters and what? They are utilized in VCOs, voltage controlled oscillators. So remaining matter we have to discuss in next lecture. Here our first unit, semiconductor diode, is going to end.